Awesome. All right. Thank you guys very much. I really appreciate opportunity to share a little bit about DataDx with you guys. We've been coming to these user groups for a little bit off and on, and we use Power BI as a core component of our product. Actually, pretty much the key visualization component. So pretty excited to get to share a little bit about that with you guys. My name is John Mattis. I'm pretty much just going to do a little bit of an introduction here. The main presenter is Ben Lawrence, who's going to go into some anomaly detection systems that we have developed, as well as some documentation that we've developed, some interactive documentation. I think it's going to be pretty cool. Real quick, wanted to give you guys a little bit of a background on who we are at DataDx. We work with provider clinics, providers in general in the medical space, and working with connecting their disparate data systems through custom applications, primarily through visualization of reports and dashboards and models that we create for them. It's a little bit of an insight into our pipeline. It's pretty high level, but these clinics, they have a lot of different data systems. They've got accounting systems, they've got EHRs, they've got billing systems, and most of the time they've got pretty good visualizations within the software themselves. So if they log on, for example, to QuickBooks Online, they can see all sorts of reports that are great for the QuickBooks data that they have. But when it comes to actually merging that with some of their productivity data or some of their billing data, it can be kind of a pain for them. So they have to pull data out from each of these systems, which a lot of times these systems don't want you to pull data out of them very easily. And then they have to combine them a lot of times using Excel. This takes usually admin staff hours and hours of time. So what we try to do is connect them via custom C#.NET application that we've developed, ingest that data through Azure into our Azure Data Lake. And I'm not going to spend too much time on that. It's kind of the focus more is on this side of the pipeline, but just kind of want to give you guys a quick background on that. And then Greg, if anybody has any questions, you mind throwing them up to me? I can't see the chat right now.
Oh, I was just putting different stuff in the chat, not questions. Nice. You're good.
Nice. So middle layer application, ETL is primarily based on Databricks. Now this is changing a little bit. I'll go into that in just a sec, but right now it's PySpark, a combination of Spark SQL that we use for our ETL, and as well as anomaly detection, which sits on top of our data warehouse. And Ben's going to go a lot more into the detail of that, but pretty much what it is a system that sits on top of our warehouse and continually checks for anomalous data and then feeds that back to us through a series of dashboards back to the client as well. And that's run using, well, right now we're switching both of those to use Azure Functions. Makes a little bit more sense right now for our pipeline. But yeah, if anybody's got any experience with Databricks, Azure Functions, I'd love to speak with you after this, because we're neck deep in that right now. The rest of it is pretty much Power BI. You know, we've got table valued functions feeding it to a Power BI data set, and then Power BI embedded into a custom web application. And I gotta give a quick shout out right now to CSG Pro. I know Greg is probably getting a little embarrassed by this, but they've been a huge help. I know a lot of you guys probably know them for the Power BI side, but they really do the whole stack. Their whole stack shop, you know, definitely worth talking to.
I'm blushing, John.
Yeah, blushing. Oh good. I can't see it. The video is not showing up, but I imagine. How many people do we have from CSG on right now?
Oof, there's got to be at least 4 or 5 of us.
Yeah. Hello.
Brian's Who's here. That? Oh, nice. What's up, Ron?
Brian.
Ron. We got Brian.
Brian.
Sebastian. Hey, quite the team. Oh, Rachel. Oh, wow. We are graced with Rachel's presence.
And she hasn't chimed in yet.
Just waiting for a good moment.
Well, I'm gonna keep this real brief. I'm gonna guys just a real quick demo of the tool, just to give you guys some background, so that when Ben goes into the anomaly detection, some of the documentation, you guys have a little bit of context about what it is. And bear with me for just 1 second, because
one question actually came up.
Yeah.
While you're getting all set up, why table valued functions and why not Databricks tables?
Databricks. So again, we're moving a little bit away from Databricks, primarily because of the cost. And again, the development environment is just a little bit difficult for our developers to work with, and within the notebooks, the Spark SQL and PySpark just doesn't come as natively as the just regular SQL and then working with pandas. So that's a big reason we're moving away from Databricks. And then because we already have the data warehouse, table value functions just kind of work easily for us. Really, we're not really doing much in table value functions other than a couple data type changes. Primarily, what within the data warehouse is the model that fits within the Power BI data set, but there's just a couple really last minute tweaks that we need to make within there. All right, let me share my next screen. All right, let me know if you guys can see that.
Yes.
Sweet. Awesome. Oh yeah, there's the sorry Team Bastion, I tanked in the second round. I was trying to pull this.
That's all right.
So this is just kind of a quick view of one of our home pages. This is a demo. This is all fake data, obviously. And this is our web application. We've got some navigation bars up here. We've got just some quick links to some news down here from our blog posts. And this is a customizable, just very quick KPI dashboard that allows clinics to log in and see what's most important to them. This clinic in particular is interested in patients. RVUs are kind of a measure of how complicated a procedure is. And net collections obviously is important. We've got to split out by per patient and per RVU. Some other good things like total debt to equity, days cash on hand. These are really, really important to clinics right now, especially as a lot of them have been forced to shut down, furlough a lot of their staff. These metrics really help them to understand what they need to survive the current crisis. So I'm going to jump into a couple reports real quick. And I'm not going to dive too much into the interaction side of them. You guys are probably pretty familiar with, normally these demos we go through and we show that you can interact with the tables and you can use these filters and look how cool it is you can interact with your data. You guys probably are familiar with all this, tooltips, you can drill into each of these tables and view similar roll-up, but I figured I'd focus on kind of 3 reports real quick that kind of go back to the different data systems that I was talking about. Connecting that's kind of a big purpose of our company. So this is primarily based on general ledger data. This is a pretty simple report that just kind of shows revenue and expenses over time. You can drill into each of these. So if you want to look at administrative expenses, there's multiple layers of hierarchy within that. What we do primarily on the account side is we take the individual accounts that clients have, and they can always filter by all these, but we map them to DataDx chart of accounts, which is a hierarchy, and it allows them to view things at the detail that they want. And that's kind of the purpose of our reports, right? Or a big design goal is you can look as low or high level as you want. If you're a doc, you just want to log in, you want to see these high level numbers, this is all you have to do. You just want to get an idea of how your practice is running, you can do that. But if you're an administrator or you're a particularly involved owner, you can start drilling down into these into the hierarchy and see how your accounts map to the DataDx chart of accounts. This also allows us to benchmark with other clinics. So if you want to look at a similar specialty or you want to look at a similarly sized clinic, you can definitely do that very easily. And next one I'm going to show you guys is AR aging. Now this is based on the billing data I was telling you about. This is again real simple report. They can log in. They can see where their claims are. How long each claim's been in aging, the total amount that's in aging by day, and there's some certain industry standards that are built in that we try to encourage them to meet these metrics, and they can always work directly with us or consultants or anybody on our team to help understand what to do with this information. Again, there's a lot of options you can go into here, but in the interest of time and to get to Ben's more interesting stuff, I'll just show the last dashboard real quick. Here is payer analysis, and this goes back to like the electronic medical record data, right? So looking at the types of patients that you're seeing and the types of coverage that they have. This is really important for clinics to understand. How much is Medicare that they're getting? How much is Medicaid? How much is commercial? How much are workers' comp? All of these different systems pay them differently. and they really need to keep an eye on what types of patients they're seeing in each of their clinics. Again, you can drill down into each of these. You've got a large number of filters for providers, specialty. You can look at departments. You can look at how CPT codes are codes that reference the actual procedures that are performed on a patient. So all of these you can look into, but I'm going to flip back real quick. Any more questions, Greg? You there, Greg?
Yes, if I can go off mute. There we go. Am I off mute now?
You are. You are.
Okay. I'm not seeing any questions in chat, but I will say, you guys are working with very difficult end users. Of course, doctors and administrative staff, and so what you've created is a really fantastic, managerial report that people can actually act on, right? And you're actually helping drive, data-based, data-driven decisions for an industry that's been kind of lagging.
Yeah, for sure. And that's, I mean, even amongst the big players, the huge, multi-state hospital systems, their analytics are very slow to adopt. The data is difficult to work with. It's difficult to share, both for privacy reasons and for a number of other technical reasons, which we'll get into right now. Kind of frustrating with some of the vendors that are available. But we definitely make it a big point to provide actionable data, and that is both in the form of dashboards. We have people on our team that understand the business and work directly with them. So it kind of works hand in hand on both sides of the business. And the last thing I got to say before I hand things over to Ben Lawrence, we are offering a free 90-day trial right now. Like I said earlier, providers have been hit particularly hard, and everyone's been hit pretty hard by this crisis. But yeah, in particular, they've been seeing a huge decrease in their revenue and a lot of staff layoffs and furloughs that they've been having to deal with. So because of that, we're offering a free 90-day trial. There's no strings attached, nothing. We want to make sure that these clinics can get a better understanding of their business so they can stay open, and we can make sure that physicians stay independent if they'd like to. So if you know anybody that's working for a provider, is struggling, and needs a little bit of insight in their business, please ask them to check us out, and we'd love to have a conversation with them. So with that, I'm going to hand things over to Mr. Ben Lawrence, who's probably going to have a lot more interesting things for you guys to talk about. We have some pretty cool stuff that we've been working on here at DataDx, including anomaly detection and some documentation, interactive-wise, that I think you guys are going to enjoy. So thanks again for having me. I appreciate the opportunity to speak.
All right, thanks, John, and thanks for all your help with everything I'm about to show, especially with all the work you did coding the anomaly detection system.
Snaps for John.
Is my Power BI dashboard showing up?
We are seeing your desktop, yes.
All right, great. All right, so before getting into the anomalies, I wanted to start off by showing how we've incorporated Markdown into our Power BI reports to make definitions easily accessible. I'm sure many of you have struggled with creating and displaying meaningful definitions in your reports. At DataDx, we've tried a number of different ways to accomplish this. Internally, we have the model tab right here where we can define relationships and create definitions. And by the way, this definition right here was created by CSG's own Rachel Dyer. And I'd like to thank Rachel again for creating pretty much everything we have set up in our Power BI reports. Anyways, these definitions can come in handy internally for our developers, where we can be technical about the data or refer to DAX. But what about client-facing definitions? So going back to the demo John just showed, this is how we used to do it. We just had a single glossary of terms page where we lumped all of our definitions together here. And this works okay for the most part, but it starts to get unwieldy as our definitions grow, as we build more reports. So our second method was using tooltips.
Hey, Ben, real quickly, as much as I love seeing my face, in your bottom right-hand corner, that little, there you go. There you go.
Yeah, so the second approach is using tooltips, which also works great unless you have a really long definition like this that barely fits on the screen. It's a lot of information packed into one place. So our final approach was a single link to a Markdown page. And if this demo report looks a little nicer than the reports John just showed, that's because this is a preview of our V2 model. A lot of work from CSG went into creating this new and improved model. But back to the Markdown, we actually got this idea when Matthew Mitchell from Central City Concern presented here in February, where they linked directly to PDF documents from their reports for measure descriptions and definitions. So similarly, we can click on this link right here and go directly to this Markdown page. And this Markdown page links directly to the report we were looking at. It gives a description of what the report is, some other fields like the default date range, the original data source, and then every single field that's used in that report is defined. Everything here is hyperlinked. You can click on charges per provider, and that's an equation, but then you can then click on charges to get the definition of charges. And everything is hyperlinked. You can click the back button to go back to where you were. This also can function as a standalone document if you want to learn more about our reports. This is a public GitHub hosted Markdown page. We include screenshots. This is pretty much a living document. It's constantly being updated. You can go to the commits tab and view all of the changes we've made. I've had a lot of help from our project manager, Cassie Randolph, in creating a lot of these definitions. And then you can even view the raw code if you want to. So if you're not familiar with Markdown, this is what it looks like. It's just a simple text language that translates to like the pretty HTML that we were just looking at. All right, any questions on the Markdown? Okay. So the next thing I want to talk about is our new anomaly detection system.
Real quickly, Ben, was that a public GitHub that you guys are using, or?
Yeah, it's public.
Cool.
Yeah,
That's pretty awesome.
Yeah, thanks. Eventually, we'll probably just convert the Markdown to HTML. It's really simple to do. Then we'll probably host it on our website, but it's a work in progress right now.
Yeah. And, I don't know if Glenn, if you want to drop that link that you were showing, if other people want to peruse.
Yeah, sure, we can add it in the chat. But the next thing I wanted to show is our new anomaly detection system. And anomaly detection, also known as outlier detection, is a way to identify values that significantly deviate from normal values in a data set. Anomaly detection can be used to identify things like credit card fraud, campaign donation irregularities, or finding new galaxies. In our case, we're using abnormal values within political and financial information. And then there's two kinds of anomaly detection that we use: outlier detection and novelty detection. With outlier detection, we train the model against a historical data set, and we get the data usually from the sources John mentioned, like electronic health records or accounting systems. And then we get that historical load and can throw X number of years into the anomaly detection outlier part of it. And that'll help us identify normal versus abnormal values. And then as new data comes in, we can use the novelty detection to predict if any of the new data is anomalous. There's also a number of different anomaly detection methods. Here's 4 examples right here. And in these charts, you can see that the orange values are classified as normal values, while the blue values are classified as anomalies. And we ended up settling for the isolation forest method, and that just proved to be the most accurate after a lot of testing from John. And we can't use this local outlier method because it's not able to detect new anomalies.
Can you maybe explain the forest method just for those that might not be data science whizzes?
Yeah, I actually have an example right here.
Awesome.
So this code right here was taken directly from the scikit-learn website. Scikit-learn is just an open source machine learning library for Python. In this example here, this gives a little overview of how the algorithm works. It isolates observations and then randomly selects features and then splits those values between minimum and maximum. And then there's some code here that helps visualize that. This code is pretty similar to what we really do at DataDx. In this example, it generates a training set of normal values based off of a normal distribution, and then it tests those values against other normal values, and then some anomalous values that are just across a uniform distribution. So what that looks like visually is this. If this was our data, you can imagine the white dots as a historical data load. And then the green and red dots are new data that comes in that we test for anomalies. So the green dots show up as regular values and the red dots are abnormal values.
And we had a quick question come up. Are you using the sklearn Python package to execute your detection within Power BI using Python visualizations?
Yes, we use the sklearn package and we run it against our Azure SQL database, and then we translate the information that produces into Power BI reports that I'll be showing in just a moment. So I think it's important to highlight for anomaly detection that it picks up values in between in between 2 points of data, and it's not just looking for out of threshold values. But related to that note, we do have a second form of anomaly detection that we call business rule violations. And business rule violations detect things like a new provider identification number appearing that we don't have mapped, or it can detect anomalies based on certain thresholds. And I have a simple example for that too. So this is an example of just a list of patient ages that we have in our database. And all of the data I'm showing, like John mentioned, is obviously fake, and it was created by taking a random sample of all of our data and then using Python NumPy randomization functions to just randomize it, and all identifying information was just scrubbed. So looking at the patient ages, we can see typical values of patient ages. And then for the business rule violations, we take any value below 0.1 percentile or any value above 99, any value above the 99.9th percentile, and we mark those as business rule violations. And as you can see, values in the negative or values over 100 are marked as violations. So this works pretty similar to the anomaly detection. As new data comes in, we train it against the initial historical load. And then if new values come in with patient ages in the negative range or over 100, we'll mark those as violations. And here's an example that highlights that. All the red values are marked as rule violations. So finally, what does this look like in Power BI?
We have some questions coming, if you don't mind, in this transition. Okay, we got two. First one is this Python code detection run in a shell script batch process or is the stored as an output as a graphic file? I don't know if I got that right, Mark.
Is this pertaining specifically to how the anomaly detection is stored? Or
Mark, if you want to jump off, yeah, he says yes.
Yeah, right now we're storing the values in joblib files, and it's mainly a local process right now, but I think we're planning on moving it to either Azure Functions or Databricks in the future.
Awesome. And then Karan had a great question of which accuracy metric, precision, recall, etc. do you use for the mentioned problem?
Can you elaborate a little bit on that?
And Karan, feel free to jump off mute if you can.
Yeah, my question is, there are different metrics you measure your model performance on, whether it's a precision, which is like total positive divided by all the positive that you say that from the historical data, or do you use recall, or the overall accuracy of the model?
I can jump in on this one, Ben.
Okay, thanks.
Yeah. So we're using unsupervised learning for this. So accuracy metrics are more appropriate for supervised learning models. So where you actually have some metrics. So if we had values that we knew were anomalous and we were trying to pinpoint those, then we'd be using an accuracy metric. But really, the goal for this model is to identify values that we've never seen before as being anomalous. So in that case, the accuracy metric, yeah, we would have to go through and label it ahead of time, which we're not doing. So there, yeah, it's because it's unsupervised, it wouldn't really be using an accuracy metric.
Okay.
Thank you.
Yeah, we do have the capability for clients to report if values aren't actually anomalies. And I'll be showing that in Power BI here in a moment. But for this initial report in Power BI, this is just an overview page, and it gives you a snapshot of all of the anomalies. The top two charts show you how the data is spread out per feature. I think John went over most of these terms, and if you're unfamiliar with any of these terms, I'll be showing the Markdown pages for them soon. But using amount as an example, you can see that the values lie between -7 million to 7 million. And then if you highlight over the box plot, it'll give you some descriptive stats about the values. And then the histogram over here on the right is showing similar information, except it lumps all the values into bins. The bottom right chart shows the number of anomalies by detection date. And the initial spike at the beginning is due to running the anomaly detection against the historical data set. So we can filter out those historical anomalies with the date slider. And then the bottom left table contains detailed information about the anomalies, like the table the feature came from and the feature values, with these 3 columns right here being created in DAX. So to show if the rule an anomaly is also a rule violation, we had to create a relationship in Power BI, one-to-one relationship on the values, and then we can use some DAX, a calculated column in DAX to see if those values are equal and just show if that is a rule violation or not. The severities are created by measures. So the severity rank is calculated by the anomaly score. I think I forgot to mention that earlier. Every anomaly has an associated anomaly score, with a higher score indicating a higher likelihood of an anomaly. So for this measure, I'm using rank X, and then I'm using all selected to make sure that these values update dynamically when you change the filters. And then I'm following Brian Grant's advice and using the long formula for the sum X here. And then for the severity, I'm just using a switch statement to rank the anomalies by their anomaly score. And again, this updates dynamically. So the severity ranks and the severity itself will update depending on what you're looking at.
That's pretty slick.
Thanks.
Does anybody have any questions on, maybe how they structured that DAX statement, or all making sense for y'all? Brian says he loves your long form DAX, as you'd expect.
All right. Oh, yeah. And then lastly, in this table, we can see the detection date. And then this is what I was talking about with the anomaly fix. So for instance, this amount of -7 million actually was reported by the client as not being an anomaly. It was a voided transaction. If they fixed the value, it never actually went through. So if you have an anomaly that's fixed and you're a user that's viewing this report, you can click on this attestation form, fill out this information, give us any feedback or report the anomaly is fixed, and then we can fix that anomaly in our database. And you can also filter out those fixed values too. So this page only shows anomalies, but what if you want to compare anomalies to the normal data? And that's what the rest of the reports are going to show. So this first report shows when anomalies occurred according to the real dates of service. You can hover over to see the number of anomalies by year. And we're using a dual y-axis here to distinguish between isolation forest anomalies here on the left axis and business rule violations on the right axis, because business rule violations occur so much more frequently. So to get to this point and merge the anomalous data back onto the source data was honestly kind of tricky, and it took me a couple tries to actually find a method that would work. And I kind of want to go over the methods I tried, because it might be helpful for people. So my first inclination was to use Python. Python is my programming language of choice, and I was happy to find out that Power BI supports using Python code. So if you go to the Transform Data tab, here's an example anomaly table that just has the anomaly feature and the value. And then here's an example of a source table that just has all the values. So the problem here is to align these two data sets. You have to pivot the feature values. So every feature needs to be its own column with its associated value to match the source data. So the first thing I tried to do was do that in Python. And it's pretty cool. You can run Python code in Power Query. This was the example script I ran. You can define your Power BI tables as Python pandas data frames, and then you can do all your data cleansing and manipulation right here within Power Query, and it runs off of your local installation of Python.
Wow.
So I ran this code and it created a bunch of temporary tables to work with the data and ultimately end up with the table I wanted, which was this one. And if you click on that, it'll load the actual table. So this is the table I wanted, has all of the source table values, and it has flags indicating if that amount is an anomaly, the date the anomaly was flagged, and if that anomaly was fixed. So now I can create those Power BI reports that I just showed. Another thing to watch out for if you're using Python and Power BI is that Python doesn't like Power BI dates, and it converts all of the dates to this. So to get around that, you would go into your source table, convert the date to a text format, and then you can work with it in Python.
Why does Python do that?
I don't know. I just found the solution on the Power BI forums.
Was that only one? Was that like one of few things that you kind of ran into using Python within Power BI? Has everything else been kind of smooth sailing, or?
There were a couple other things. Honestly, it's kind of buggy overall. It would error on me a lot, and then I would just retry running the script and it would work. So it's not fully fledged yet, I don't think. And the biggest problem was I couldn't schedule refreshes. So in order to
Buyer
make this
beware.
yeah, I mean, I think they're still working on features and hopefully it'll be more fully fledged in the future, but Python just wasn't going to work for us because we wanted scheduled refreshes.
Right.
So the next thing I tried to do was use Power Query itself. And in Power Query, you can do merges and stuff. You can go to the transform and you can pivot. Where is pivot? But you can do all that data manipulation in Power Query and you can pivot. Oh, there's pivot. So I can pivot on the value column and that'll do exactly what I wanted and spread everything out into its own column with its values. And then you can do all the merges and stuff. But I felt like that was still a little too manual and I wanted to find a better solution. So what I ended up doing was I just used DAX. Here's some example DAX. So I first created a calculated column and I used the contain statement to filter just amounts. For in this particular one, I wanted to show amount anomalies. So I wanted to show where the feature was an amount and where the anomaly wasn't fixed. And if that value matched the source data, output anomaly. If not, create a blank. And that worked great. The beautiful thing about the contain statement is that you don't even need a relationship set up for this to work. And then from there, I was able to create measures. Measures that just counted the number of anomalies per feature. And that's what this chart is using. So ultimately, I think using DAX ends up looking cleaner, it's easier to reproduce, and it's likely more efficient than the other methods I tried. So the next report shows anomalous credit amounts. You probably know what a credit amount is, but we also have this handy link to our Markdown page just in case. And a lot of these reports highlight how the isolation forest model is able to pick up anomalies within the data and not just outside of the data, like our threshold limits for the rule violations. You can see that the rule violations only pick up a few values around the 2 million mark, while the isolation forest picks up all these values in between. And we can filter to just anomalies to really highlight that and see all this anomalous values. Well, there's only a couple business rule violations that fall outside the thresholds.
Do you find using those, the anomaly detection, the end users have a way of kind of saying, oh, here's an anomalous value, I know what to do next? Or was there some, training or interpretation that you have to make for them before they can really take action?
Sean, do you have any experience with this?
Yeah, I mean, it really depends on the user, obviously. I mean, there's some people who want to dig into this level of detail and they want to see exactly how far away it is. And I think a lot of this helps out with the development team as they're doing the ETL process. I mean, you run into, issues all the time, and then you dig into it hours later, you find out that it was some value that you weren't expecting that's causing the issue. So that helps out a lot on the dev side. But on the client side, it really it comes down to, like I said, who is going to be looking at it. I think we generally try to put it in front of them as, hey, here's some values you might want to look into. Send them a note if it's particularly bad, and then start to train them on this is the system that you can log in. You can look through and monitor this on a regular basis. But it really depends. We're looking at setting up some alert systems so that people can be alerted rather than having to log in. That's a next big project for us on this.
So that's a great suggestion here. As more organizations are bringing on AI capabilities, it does take a little bit more handholding from your BI team, and it sounds like you're getting dual purpose out of it. Not only are you working with your clients, but it's helping you kind of form your ETL and data processing as well.
Yeah, honestly, for the ETL side, it's worth it by itself. If you guys are interested in looking into this kind of system, it has saved us a bunch of time on that side and really improved the quality of the reports that we put in front of the clients the first time they see it. And also, there's been at least 4 or 5 examples I can think of off the top of my head where there's been some extreme value that has been within their source system. And so we're working to improve their source systems too. We let them know about, I think Ben was saying, really old patients, like we had like a 120-year-old patient at a pediatric clinic, and let them know that patient had visited them about 60 times in the past year, and they were able to get it and change that.
Wow. That's awesome. Does anybody else have questions for these guys? I think what they've built here and how they've really just, extended the use of this platform to, kind of fill all the needs of their end users has just been fantastic. Crickets. Do you guys have more to share, or is this where I start giving my snaps?
If we have time, I could briefly show a couple more.
You got time.
All right, great.
Five more minutes.
Cool. So this table right here, I think, really highlights the benefit of merging that anomaly data back onto the original source data. You can see the actual date where the anomaly occurred, and then we also show the anomaly detection date and the rule detection date, and these are both calculated using DAX. This next report is a CPT code anomaly report, and this is actually our newest anomaly report. And that's because we didn't really try putting CPT codes through the anomaly system before, and that's because the codes they're always 5 digits, but they can be numeric or alphanumeric. And the isolation forest doesn't support alphanumeric values. So to get around that, we use a Python pandas function called toNumeric, and then we try to convert every value to a numeric value. And if it can't do that, it just replaces that value with a blank. So we're looking at values, only the numeric values right here. We can also do that same thing in DAX. So in DAX, it's just if it encounters an error, replace that value with a blank, and that's doing the same thing as the toNumeric does. So the CPD code anomaly system is pretty important. If we look at the anomalies, this one was actually reported as fixed since it doesn't fall in that 5-digit range. But if we filter just the anomalies, we can look at the actual code description here.
Got some questions coming in, by the way. This is a good
Okay.
time to. Got a few. So, how often do you need to retrain your model? Is one.
Okay. I think that's kind of dependent on the client, and I mean, we typically do a historical load, but then if we get a lot more data, we'll probably want to run the model again. John.
Okay.
Yeah, I mean, like we try to stick to a weekly basis, but like he says, it's you know, it really depends. If there's some clients who are generating very little data, that's not really necessary to run it that often, or if there's some that are generating a huge amount of data, we might kick that up. But pretty much, I think weekly is about the threshold that works for us right now.
Got it. And then to clarify, your base anomaly scoring is done separate from Power BI using Python in this batch process that then stores the value in the SQL database. I think you guys had that one image. Is that the correct understanding?
Yeah, that's exactly what happens.
Cool. And then lastly, Malcolm asked, what is the largest data set by row count that you have processed using this method?
John, what do you think? Maybe 10 million?
Yeah, that sounds right. It's hard because, like Ben said, it's really the longest time is the initial historical load, right? Because that's the difference between the anomaly and the novelty detection. The anomaly detection, you want to run that just once, and that's going to train your models, and that's going to take a little while. And that we run on probably the 10, 15 million rows. But then on a regular basis, when we're running this, the novelty detection on a daily basis, that's usually much smaller because most of these places aren't generating millions of records every single day.
They don't have millions of patients?
I think they wish they did.
Yeah.
Yeah, and actually these next two reports were ran on over 1 million rows of data. And that's kind of the reason I'm not able to use the box plot, because plotting that many points on the box plot Power BI blew up on me. I mean, it tried to plot some, but it gave me a warning, like, we're not displaying all the information.
So I have a question. I'm just too lazy to type it. I think it's an amazing presentation. So thanks a lot, you guys. Can you just say a little bit more, Ben, about mapping back to the source? Like maybe I missed it, but what is that really all about? I mean, mapping the anomalies back to, yeah, just anything more you could say about that.
Well, it's mainly it's because the Python code generates a table that looks like this, where it just tells us the feature for the column that it detected an anomaly on, and then it shows you that value that's potentially anomalous, and it usually has an isolation force score, where again the higher score means a higher likelihood of anomaly. So just in order to get this format in a format that is able to merge against the source data, we have to pivot this data and translate these all into their own columns in order to do that merge back to the source data set.
But so you're not actually sending it back to the source, right? Or
No.
are you? Okay.
No, they would not like us doing that.
Yeah, I was going to say, like, what are you doing that for? Anyway, cool. It's
we
amazing.
fixed your data for you.
I mean, the other thing I just want to say is that, like, for me, this is such a tremendous way to do data profiling. So, you're bringing on a new client. They really don't know where their problems are. Boom, you put this against it, and is it saving you a lot of profiling time? I mean, you sort of implied that, John, but I mean, it seems like great way to clean it up, or tell them what they need to clean up, right?
Yeah, it's hard to quantify because you don't know how long it would have taken an analyst to fix a problem that you identify with this. But yeah, we don't have to. We don't have to.
Yeah. Anyway, it's really great. Thank you.
Well, we have one last question that I think is really great that Mark asked before we transition over to our other Mark, Walter. He was asking, how do you set up your tenancy for your clients, with Power BI embedded, how are they accessing these reports? Maybe if you want to touch on that.
That's we use RLS primarily, so most of it's stored. If it's a similar type of clinic within the same data model, although we do have some other types of like dental clinics, which are just slightly different enough that we're bringing on board right now that we might need to change up that approach a little bit with. But yeah, primarily we're separating this out through RLS.
So you basically have Power BI embedded, and then you have the reports, which the users authenticate through, and then you have a large data set that when the authentication is passed, row level security is actually taking care of filtering the data. You don't have like a multi-tenant environment.
No, it is a multi-tenant environment, Ron. Here, that's the interesting thing about this solution, right? All these clinics and their data exists in one database in RLS. Kind of segregates that data in a way that needs to be done to present it.
Yeah, and that's the big reason that when I was showing the pipeline earlier, we have a separation between the data lake and the warehouse, is because we want to make sure that we have a copy of how it exists in the client source system before we do anything to it. But we do find that once we're able to normalize, most of the time, the data at these clinics is pretty similar.
Awesome.
So they fit pretty well together.
Awesome. Well, we're right at a little over 7. So how about we give you guys some snaps? That was awesome. Congrats to Ben for first presentation at the user group.
Great job, you guys.
Thanks a lot, John, for supporting. Congrats to DataDx for all you guys have done with your product, and thanks for plugging us, for helping y'all out. So yeah, if anybody else wants to go off mute and give them snaps too, you're welcome to do it.
Really quick, I say one more thing, Greg. Sorry.
Yeah. Go for it.
I just wanted to highlight that the business rule violation thresholds can also be helpful to us. This is one example of the patient ages that the anomaly detection couldn't really pick up, that values around -1 to -2 were anomalies because they occur so frequently. So our business rule violations did pick up that these were anomalies. So I just wanted to show that they are helpful sometimes.
Awesome.